Assalamualaikum and good morning again. My name is Nur Sakya Matematik and my project title is IT Device Development, Logic and Forensic System. So the main purpose of this project is to develop a forensic logic and logic system that record device activities centrally and help investigators reconstruct security incident. Uh, so many smart access control system focus only on access functionality. But like proper forensic looking. So when incidents such as unauthorized access attempt, authentication failures, or device tampering occur, it becomes difficult to identify what happened because the log may be incomplete or altered. So therefore, this project aims to provide centralized logging, integrated verification, and timeline reconstruction for digital forensic investigation. For a problem statement and objective, so there are two main problems addressed in this project. First, many IoT smart access systems do not have concept debugging mechanism. So in making investigation difficult to decide whether it's valid or not. Second, attackers may modify or delete local logs, affecting the integrity and reliability of digital evidence. So the objective to solve this issue is to study forensic logging methods in smart door log IoT system to develop a prototype IoT device management system using Sharp to basic function and timestamp logging and to test the system capability in detecting log tampering and supporting incident reconstruction. So for literature review, several previous studies relate to IoT forensic logging, forensic analysis effective, and access control security were examined. So most studies highlight the importance of centralized logging, integrity verification, and timeline reconstruction in improving forensic investigation. So based on this finding, SHA-256 machines and centralized database logging was selected as the cost-control mechanism for this project. So for the system recovery, the section show a power architecture, support diagram, and database design for the system. It consists of ESP32, graphic, authentication, web server, MySQL database, and a monitoring dashboard. So for total development, the system includes a login page for admin and user authentication, OTP verification page for additional security, a dashboard page for monitoring system activity, user accessible door model, user accessible keypad pin console model, and the simulator for testing access event. So when a user scan or interview, the event is recorded automatically and displayed on the dashboard in real time. So this I will show on the video. So for the pen test testing, all computers, including logging, authentication, access control, logging, and report generation, were tested successfully when achieved a pass result. And for the comparison action, this system expert used on smart office, SME forensic awareness, smart building monitoring, like an incident investigation platform, and last, IoT forensic monitoring solution. So in conclusion, this project successfully developed a forensic IoT device, and the system provides centralized logging with strong to forensic action, integrated verification, and real-time monitoring and timeline-based incident reconstruction. So for the future enhancement, the system can integrate with AI based on mobile detection, cloud forensic storage, or use a biometric authentication and mobile notification alert to enhance security and scalability. Thank you, and that's all from me. I will go to the system. the ESP32 device onto the forensic logging dashboard. Okay, first, I already connected the ESP32 to Wi-Fi network, and once it's connected, the ESP32 communicate with the server using HTTP request and sends all activity logs to the centralized SQL database. Is the ESP power on. Next, this is the login page. So I can also register if the user was not registered yet. We can register a new user. Okay, for the ID, I put the initial of the name and as the stuff. For the password, still, as you can see, it is registered successfully, so we can log in if we want to log in. So for example, next, will be shown as OTP. Then, this is an extra security. So the OTP will send to email or SMS or to the user. This this OTP can expire if 5 or 10 minutes not. Okay, this is the user interface, so they can see a dashboard, which door they can access. For example, here, it only can access one door. Forensic log, timeline, they access the. They can also generate report, integrity check. Okay, as for the admin, it has a dashboard, same which door can access. For keypad access control, if I scan the graphic, it will automatically insert this, or I can manually insert the ID. Demo the access or denied to my system. Forensic log, timeline, or integrity check if the data is tampered or not. So the data is valid. Simulator. So this is if demo if they happen to my ESP, I will try, or something happen to the device. The admin can try to see if the system or the device was the problem. So for example, I click temper alert, show the forensic log. Admin use user control, so the admin can control if that user active or not. So admin door, admin can setting if that user can scan from what to what. I will demonstrate the physical smart door. So when I scan the card, the ESP will read the ID using the rapid reader, and the ID is sent to the, my web server. So the server verify whether the ID is registered. If the ID is valid, access will be granted. So I show you. First, I will demonstrate an unauthorized access item. I scan as someone that cannot access the door. It will show a fake or block card. As for if the ID is registered or can access the door, it will show access granted. So it will automatically shown in the admin can access the door. For example, if the ID was scanned but not entered a PIN number for 15 seconds, so it will automatically deny as someone that known or block card. Since every event contains an accurate timestamp, so investigator or admin can reconstruct the sequence of event in the timeline reconstruction. For example, they can identify when a user login, scan and rough it, enter a PIN or attempt unauthorized access. In conclusion, my SP32 has successfully communicated with my web server. The unauthenticated user can access, record every security event into the centralized database, and support a forensic integrity verification, and can improve. So this demonstrates how the system can improve forensic readiness in IoT smart access control environment. That's all from me.